Hello everybody, we are going to solve question number 6 from our stress strain practice sheet, which is actually a question number 15 from a Unit 1 exam Jan 2023 series. I'll read out the question and we'll solve all the parts. A gymnast bounces on a trampoline. For each part of the bounce, the gymnast is in contact with the trampoline. For the rest of each bounce, the gymnast is in the air. You can see the diagram below. The trampoline gives the gymnast a maximum upward acceleration. Acceleration is given here. Calculate the maximum upward force of the trampoline on the gymnast, and the mass of the gymnast is given. Okay, so if I just try to quickly draw a free body force diagram for this gymnast, we know that the forces acting on the gymnast will be number 1, the downward weight, which always acts, doesn't change, and there has to be an upward force of the trampoline on the gymnast. I'll just label it as F. We are required to find this upward force of the trampoline on the gymnast. Now, one common mistake that the students do over here is they try to use F equals ma straight away for the force of the trampoline, which is a wrong method because F equals ma is only used for resultant force. So what we can do is we can find the value of the resultant force on the gymnast using F equals ma, and if I apply this formula, I end up getting 824 newtons or 823.6 newtons resultant force. Now, the acceleration is upward, therefore the resultant force is also upward. Now, if the weight is acting downward and the force of the trampoline, I'll just call it force of trampoline because I'm using F for the resultant force. So the force of the trampoline is upward and the resultant force is also upward. It means the resultant force is equal to force of trampoline, which is upward force of trampoline minus the downward weight. So if I need to find the force of the trampoline, I have to add the weight to the resultant force. So force of trampoline is equal to resultant force plus the weight, which will give me an answer of 1393 newtons, or in a standard form I can write it as 1.39 into 10 to the power 3 newtons. We must give our answers to 3 significant figures. Moving on to the next part, trampoline is made of a sheet of material attached to a frame by springs. The vertical components of the tension in the spring provide the upward force on the gymnast. The vertical component of the tension in one spring is 68 newtons when the spring makes an angle to the horizontal 14 degrees. So this is how the spring has been shown. Tension has been shown acting at an angle of 14 degrees from the horizontal, and they have given us the vertical component of the tension as 68 newtons. So this is a question for 2 marks where we have to show that tension in the spring is 300 newtons. So since we have already been given the vertical component of the tension to be 68 newtons, I can use the formula for the vertical component and rearrange the equation to get the value of tension, and on calculating I end up getting an answer of 281 newtons, and to one significant figure it will be almost equal to 300 newtons. The next part, the extension of the spring was, so we have the extension. Calculate the stiffness of the spring, which is K. Now, according to Hooke's law, force is equals to stiffness constant times extension. Now, if I want K, I'll rearrange the equation and I will end up getting K equals T over X. Now, T, or the tension, we already calculated in the previous part. Use the full 3 significant figure answer. Please do not use 1 or 2 significant figures in your subsequent calculations. And on calculating, I end up getting a value of 6108 Newton per meter for K, or in a standard form I can write it to be 6.11 into 10 to the power 3 Newton per meter. Now, this is a linkage question. Part C, the vertical acceleration of the gymnast varies while she is in contact with the trampoline. Explain how the forces on the gymnast affect the vertical acceleration while she is in contact with the trampoline. The question is clearly mentioning all the details, so please read the question properly. Your answer should identify the forces acting on the gymnast and the directions of forces. So now your answer must refer to the forces acting on the gymnast at different situations and the direction of the forces, because acceleration can only be linked to the resultant force using F equals ma, so keep that in mind. You do not need to explain this question using energy conversions. You just have to focus upon forces. So what I'll do first is I'm going to draw a quick free body force diagram for the gymnast in different situations. When the gymnast hasn't touched the trampoline yet, when the gymnast has just come in contact with the trampoline, and when the gymnast has caused the trampoline to go down, which means now the trampoline is stretched. In each situation, there is always a downward weight acting on the gymnast, which remains same throughout. Now, when the gymnast is not in contact with the trampoline, then there is only one force, which is a downward weight acting on the gymnast. No other force is acting. When the gymnast just comes in contact with the trampoline, now there is a normal reaction force acting on the gymnast, which actually arises because of the tension in the springs which are connecting the trampoline fabric to the frame, like mentioned in the previous part. When the gymnast further goes down and causes the trampoline to stretch, now there is the weight and the normal reaction is still acting, but this time the normal reaction will have increased. Why? Because normal reaction is equal to the tension in the springs, which is equal to Kx, which means when the trampoline is stretched, the normal reaction force will increase. So now let's look at how we will link this with the acceleration. So we can start by mentioning the forces, that there will always be a downward weight acting on the gymnast, which remains constant, downward weight. When the gymnast just comes in contact with the trampoline, now there is a normal reaction force, which is in the upward direction, acting on the gymnast. And therefore, the resultant force will be equal to weight, which will be greater than the normal reaction, minus normal contact force, causing an acceleration in the downward direction still, because the resultant force is in the downward direction. Acceleration is always in the direction of the resultant force. As the person or the gymnast stretches the trampoline or goes down further, this will cause the tension in the springs to increase. Therefore, the normal reaction increases, and as the normal reaction increases, the resultant force, which is downward, decreases. And as the downward force decreases, the downward acceleration also decreases till the acceleration becomes zero when normal reaction becomes equal to the weight. Now, when the person further goes down, causes further extension or stretching of the trampoline, normal reaction increases, becomes greater than the weight. In that situation, the resultant force will now be equal to normal reaction minus weight, and this resultant force will now be in upward direction, hence producing an upward acceleration. And this is the time when the gymnast will now start moving upwards. And this is till this point only you need to explain, because we have to explain for only the time when the gymnast is in contact with the trampoline.